Hello, everyone, and welcome to today's session. My name is Sayam Pathak, and I am a CNCF ambassador, working as Director of Technical Evangelism at CIVO, building the next gen cloud platform. I do regular live streams with awesome people like you can see on the screen yourself, and we, learn about all the cloud native stuff and all those things. So, very excited for today's stream, which is on Chaos Mesh. Everyone knows like chaos engineering is not only picking up space, it is now an essential need for your application to be running in production. So it is a very important aspect. I myself have given a couple of talks on chaos engineering, even at KubeCon. So very interesting topic and very interesting tool that we'll be discussing today is Chaos Mesh and the 2.0 version, which is the most recent one. What are its capabilities? What are its features? We'll see a demo as well. So a lot of exciting things for today's stream. So thank you all for tuning in, and I see a lot of people has already joined. So thank you so much for joining in. Put your comment like where you are tuning in from. It's very excited to see people tuning in from different locations. So thank you so much for joining in. Uh, Fortunately, we have three giveaways as well for today. So we'll be giving out Chaos Mesh t-shirts, and for that you just need to create Twitter threads. So that you have been creating that over the past streams. So whatever you learn from today's session, start creating the Twitter threads, and you can tag Chaos Mesh. You can find Chengweng or Kelvin on Twitter as well. So you can just tag them as well, and just tell like in form of Twitter threads like what you are learning from the stream, and how you will be planning to implement chaos in within your infrastructure or application. That would be interesting to see, because the chaos community is growing, and we are working on a lot of different aspects in the chaos engineering space. So very excited for today's stream. Hello everyone. So we have Avinash, Saloni, Viraj, Abhinav, Manitosh, Avinash. So really glad. Uh, so hi Simran. Thank you so much for tuning in. This is so glad to see all of you joining in, and yeah, we have number more folks joining in. Very nice to see you all. Great. So today we'll be talking about Chaos Mesh. Before that, if you are new to the channel, please care to subscribe, because that's what keeps me going. So subscribe to the channel and share the streams. The August is awesome because there are lots of streams coming up for you, and there's a whole WSL week which is coming. That will be pretty interesting. And I have all the experts in the WSL domain to be telling about WSL with containers, Penguin Linux, and a lot more stuff. So in today's session, we'll be discussing about Chaos Mesh, and I have Chengwing and Kelvin with me joined today, who work on Chaos Mesh, and they are super people, easy to reach out, working on amazing project. So welcome both of you, and thank you for giving your time. Please introduce yourself to the community.
Oh, okay. My first. Hi everyone. I'm Chen Wen, and I'm the maintainer of the Chaos Match, and also I'm working in PinCap, and also work on Chaos engineering many years for 3 or 4 years, and also I and present I am based in Beijing, and I. And I just want to chaos engineering can help more people to improve their distribute system and find more issues on their system and so on. Yeah. Okay.
Okay, it's my turn. Hello, everybody. I'm Kelvin. Uh, I'm also from PinCap. I'm with Chenwen. I'm one of the maintainer of CastMesh who focuses on the documentation and the content in the ecosystem. I'm also the liaison between the CastMesh team and the CNCF. So glad to meet you all, and thanks Ian for having us.
Yes, super excited for this particular stream. I have used. I mean, you already know. Like I have used Chaos Mesh, and we have a marketplace application as well on CO Kubernetes. So we have been in touch. We have been in conversations. We are working on a chaos engineering working group, and even on a white paper that we have bi-weekly meetings on. So very interesting space, and always wanted people to know more about the 2.0 version. What are the new powerful features that with the help of community and the maintainers, Chaos Mesh is growing into. So very great project. So I mean, let's get started. So yep, we can see the screen as well. So yeah, let's get started with like what Chaos Mesh actually is.
Okay. Am I sharing the desktop now, or Saim, you're sharing?
No, we can see your screen share already, Kelvin.
Yeah,
We can see
I also can
the
see.
Okay. Sorry, I'm very new to this. Just wait a second.
No problem.
Yeah.
Okay. It seems I cannot control the screen.
Oh.
Okay.
Yep.
I think I'm on it now.
Yeah,
okay, good.
That's great.
Okay. Let's get started. So here is the agenda for our sharing today. Firstly, I will give a overview of Chaos Mesh, and because I'm not on the tech side, so Chen-Wen will take you through the deep dive of the technology details, like architecture and what's new in our Chaos Mesh 2.0 and our future plans. And he will also give a demo in the end of his sharing. And finally, I will briefly introduce our Chaos Mesh community and how you can participate. Okay, what is Chaos Mesh? Actually, Chaos Mesh started out as a kind of internal testing platform to test TDB, which is a distributed SQL database. And after we do this for a while, we realized that it could be a generic platform, so we open sourced it. So we have Chaos Mesh. It's a cloud-native chaos engineering platform for Kubernetes, and it provides very comprehensive fault injection methods into a container, pod, network, system, I/O, kernel, etc. If you want to know more about it, you can check our websites and GitHub. We built Chaos Mesh with kind of mission, which is to establish a complete ecosystem of cloud-native chaos engineering. And actually, we are glad that we are not alone in this mission, because we also have chaos engineering projects like Chaos Blade and Litmus Chaos in CNCF. And we also build Chaos Mesh to make chaos engineering easy, especially for developers and SREs. Here is a brief timeline of Chaos Mesh. Actually, Chaos Mesh is a very young project. We open sourced it on the last day of 2019, and we got our first community option in April 2020, and we joined CNCF as a sandbox in July 14th. which is actually 1 year from now. And after we joined the CNCF, we got 1.0 GA in September last year, and then we just got 2.0 GA recently. And yeah, that's just now it's a timeline, and this is a very funny demonstration of how Chaos Mesh evolves. When we first open sourced it, it's like this scatter, very simple. We just provided it as a fault injection tool, and with very simple, with very simple management UI, mostly through command line. And then for Chaos Mesh 1.0, we got more comprehensive and fine-grained fault types, and we got Chaos Dashboard, which is the first version of Chaos Dashboard, which is very easy to use web UI for users to orchestrate Chaos experiments. And we got the Grafana plugin to help users to watch real-time Chaos results. And then for the Chaos Mesh 2.0, which we just released, we got more improved Chaos Dashboard, and we got Chaos native Chaos events, and we got very native workflow engine that we built from scratch, and we got something related to security, which is the authorization mechanism for Chaos Mesh. That's the simple roadmap so far for Chaos Mesh. Yeah, that's a very brief overview. And next, I will hand over to Chenwen, and he will give you a deep dive into the Chaos Mesh architecture and the 2.0 features.
Yep. Thank you, Kelvin, for that. Just before going into the architecture, there was a question on what is chaos engineering. So basically, chaos engineering is kind of a practice, you can call it, or a mechanism to induce faults into your system. So chaos engineering, so chaos mesh is basically the Kubernetes way of doing things. So it is injecting faults or failures into your Kubernetes clusters to see how they will perform in case of failures. For example, if your application is running and your pod goes down, or you have a high load of network traffic, or you have high input-output load. So all these kinds of things that actually happens in production, you try to simulate those using Chaos Mesh, and they will be inducing failures in your applications, and then you will be able to see like where your application stands in production. So obviously there has to be a lot of things you need to take care, like the blast radius. It's a very important term. Since you will be doing these in production, you have to be in touch with your teams, like you will be performing so and so chaos engineering operations for testing purpose, because to see the resiliency of the application, there are a lot of advantages. I'm just giving kind of a very high level 30,000 feet kind of overview. So you will be able to see the resiliency of the application. You will be able to see how good your infrastructure is working, because you have Kubernetes native experiments as well. Like if a node goes down, then what will happen to the pod? So all these experiments are also there. So you have Kubernetes kind of experiments. Obviously, you can inject those inside the pods, and your application in Kubernetes world runs as a pod. So internally, you are doing kind of chaos experiments with your applications, because they are running as pods, and you will be touching the pods in some scenarios, in some chaos experiments. So we call them chaos experiments. And I think Kelvin showed, like in 2.0, you also have chaos workflows. So you can define the complete workflow with that. So you have a UI where you can create easily the chaos experiments. Obviously, when you see the demo, you'll be able to see, like, all these are very easy to create from the UI itself, and very simple installation as well. So if you go to chaos mesh org, you can see there's a single line command that you have to run against your Kubernetes cluster to install chaos mesh. So it's pretty simple and pretty neat, that you can install chaos mesh on your Kubernetes cluster. It is available as some of the applications, like on Civo Kubernetes, you just one click application, like you can install directly. So that those options are also available. You have out of the box monitoring, that the Grafana plugin that you can integrate and see the chaos duration and all those things. So I think those are some of the features of chaos mesh. Obviously, when Chengwen tells the architecture, he'll be telling more, but on a high level, this is what kind of chaos engineering is, and this is where chaos mesh stands. Very rightly said by Kelvin that there are other players in the ecosystem that are moving towards same goal of making chaos engineering easy and useful, helpful for the community. So that's where the community involvement also is very important. To tell, like, these all features are required, these are the scenarios that you are thinking of doing test cases with. So that's the power of community, and that's how the kind of roadmap that gets built over the period of time. Obviously, with the maintainers already have a set of features that they want to implement, but the power of community is always there. Most of the features would come out of you people or us, like, who uses the product and the end users. So that's how chaos engineering is. That's where chaos mesh is, and that's where it is lying. So now let's Chengming, let's move to the architecture. I hope that was clear. Any you would like to add anything, Kelvin or Chengming?
Oh, okay. Thanks,
yeah.
thanks for Yemas about the introduction about the chaos mesh and the chaos engineering is very great. And the next I will show some architecture about the chaos mesh and deepen the chaos mesh. Okay. And maybe Kevin, can you stop your share? Okay. Oh, hi. Can you see my screen?
Yes.
Oh, okay. Okay. Next, next, I introduce the architecture of the chaos mesh. Let's deepen the chaos mesh. And here is this architecture image of the chaos mesh, which shows the call flows between the different components from submitting a single chaos experiment to execute injecting action in a target pod. Chaos mesh is built on Kubernetes CRD, custom resource definition. So you can also think of chaos mesh as a plugin for Kubernetes. To measure different chaos experiments, chaos mesh define multiple CRD times based on different fault times and improvements and separate controller for different controllers for different CRD objects. Chaos mesh probably contains 3 components, and here the first one is chaos dashboard. It is a web UI for user to measure and design and monitor chaos experiments, and the user can use this component to operate and to observe the chaos results. And also on chaos dashboard, we provide authorization mechanisms based on Kubernetes IBAC. And the next component is the chaos controller manager, and here it is the CoreLogix component of the chaos mesh, and which is used to schedule and manage chaos experiments. The controller manager contains multiple CRD controllers, such as workflow controller, scheduler controller, and various times of the fault controllers. And here, the next is chaos daemon. It is the main executives component of the chaos mesh. Chaos daemon runs in a daemon set mode and has privileged permissions by default. Chaos daemons merely interface with a specific network device, file system, kernels, and so on by introducing intruding into the target pod namespace. As you can show in this picture, the overall architecture of the chaos match can divide it into 3 parts. The first part is a user input and of the versions. Users can use a Kuba command to or chaos dashboard to input to submit chaos experiments or workflows to Kubernetes API server. And the second part, the chaos controller manager will receive the events from the Kubernetes API server, and these events describe the change of the certain chaos results, such as a new workflow object or the correction of chaos object. And then, wait a moment. The third part is the execution part. In this part, the chaos daemons component will receive the injection required from the chaos controller manager, and here chaos controller manager will pass us the definition and schedule chaos experiments, and then send the injection required to specific nodes. And here chaos daemon will receive the required, and then will enter the target pod and inject a failure on the target pod. Okay, next let's deep in how chaos match inject failures on the target pod. First, chaos daemon will get the PRD of the application from the container runtime, such as Docker or Containerd and the other container runtime. And then chaos match will use the PRD to find a pod namespace, such as network namespace or PRD namespace. And then chaos match will hack into the target pod namespace and perform some specific for injection. And if the chaos is network chaos, maybe we will in your network namespace and run some TC rulers or some IP tables rulers or IPset rulers and so on. And if you are a stress chaos, we will enter your PRD namespace and start a stress ng process, and so on. If you are IO chaos, we will start a few service to hack your IO action and so on. Okay, chaos match define multiple CRD times based on different fault times, such as pod chaos, network chaos, and so on, and also workflow. Here is an example of the pod chaos object, which is defined in a YAM file, and it's very simple. This chaos experiment simulate a random takeaway pod available for 30 seconds. Chaos match use a different selector to define the scope of the for injection. Here, we use the label selector. This selector will select all takeaway pod with this label, and the one motion represent the chaos experiments will select all select one pod randomly from all pod that meet the defined selectors. And the direction represent the fault injection will last 30 seconds. And here the kind define this, and here in the action define the fault action is the pod failure. Yeah. And this is a basis chaos object. If you want to define some schedule rulers for chaos experiments, you can use a schedule object to define it. And this ruler is same to the cron job in Kubernetes. Okay. Chaos match also include a native workflow engine, which is decided for chaos match and used to design a chaos scenario to manage a group of the chaos experiments and a set of the status checks of the application. And here is also example of the workflow object, which merely contains 3 parts. workflow name and the entry. The entry is the entry of the whole workflow, and also a set of the templates. And the present chaos match workflow support 5 different types of the templates, and here serials, parallels, and chaos, and the suspense are task templates. Serials and parallels templates define the rulers to run the real task, and the chaos templates is used to define the specific chaos action, which will be translated to different chaos types, such as pod chaos, network chaos, and so on. Task templates is used to define some custom task, such as we can use this to define the status checks, and if you just want to run a share screen, you also can use this task templates. And the serial and the parallels and the task templates are alone another templates to be referenced and their child nodes. This workflow is very simple and easy to use for users. You can and also you can define the workflow on Chaos dashboard. And here just a YAML file example. Okay. Okay. Next. Maybe...
Yeah. Just one before we dive into like Chaos Mesh 2.0. Can you go to the architecture diagram?
Oh, this?
Yep, this one. Can you click there? Yeah. So can you zoom in? I mean, can you put on the presentation mode?
Oh.
Can you present it? I mean, full screen.
Okay.
Yeah, so basically, if I understand Chaos Mesh architecture correctly, so there are 3 major components. One is the Chaos dashboard, one is the Chaos controller manager, and one is the Chaos daemon. So user, as in me or the community or anybody, user will be interacting with the Chaos dashboard. So in the Chaos dashboard, you'll be creating the experiments that you want to perform on the Kubernetes cluster, and you will be selecting the options and all that, and create the experiment and create the Chaos experiment. Now that request now goes to the API server and falls to the Chaos controller manager. So Chaos controller manager will then see like what request has come, and will then create a respective Chaos daemon that will be responsible for performing the actual chaos within the node or within the actual pod. And it will get the PID of the from the container runtime. It can be containerd, CRI-O, or Docker, and then it will find that from the PID, it will be finding that particular container, and then it will be injecting the chaos whichever is there. And as a sidecar, it can it can also hack some of your workloads or the pods using a sidecar container, and then inject itself as a sidecar and perform its operations, and then give you back the results. So that's kind of how the Chaos Mesh would work. Obviously, you can, since it's a CRD based, so you can create a custom resource. You can create YAML file if you are a YAML fan. So you can create a YAML file of the Chaos experiment, directly do a kubectl apply of that YAML file. Then also the controller manager would pick up that YAML file and perform the chaos. So I hope I understood the Chaos Mesh architecture well.
Yeah, well, great. Your introduction is very good.
Okay, cool. So now let's move to the Chaos Mesh 2.0 features.
Okay, let's move. I will continue to introduce the new features in Chaos Mesh 2.0 version. Okay. Make chaos nearly easy is our goal. So this year, we do many things on ease of use and observabilities. First, we continue to improve the chaos dashboard component and make it easier to use. This version reduces the steps to create chaos experiments and support more chaos times and workflow on chaos dashboard. In addition, Chaos Match uses native Kubernetes events to show the detailed information and the steps of the chaos experiments. And you can get the chaos events from chaos dashboard or executing kubectl command. And here is an example. You can find the chaos events on chaos dashboard. And here is the definition. And here is an example of the chaos dashboard. And also we has a new tools we call chaos control, which is tools to help user to debug issue and to collect logs from chaos match. Okay, next is functionality. We have a new object that we call it schedule. If you want, the user can use it to define chaos experiments with cron rulers, and the rulers is the same to a cron job in Kubernetes. And here you can find it on our chaos dashboard schedule, and then you can define some schedule rulers and here. And next is a workflow engine. And this native workflow engine is developers in this version, and also users can use it to define their chaos scenarios. And here is just an example. You can see that we defined many chaos experiments one by one, and here you can run the chaos experiments in the workflow, and also you can define status checks on workflow, and also you can stop or control the workflow, how to work, and here. Yeah. This year, we also expand the chaos times such as stress chaos, DNS chaos, and also GOM chaos. You can use the chaos match to simulate some failures on GOM application, and also we support to simulate some failure on AWS node and the GCP node, and also and other chaos. We try to cover more of the times of the failures we may encounter in the real world, and here is a new component we call it Chaos D, and here is is used for user to inject the failures directly on not Kubernetes nodes. And this the failure level is the node, and in the next step, we will integrate Chaos D and Chaos Match together on a unified dashboard. And use this component, you also can inject some failure on your Kubernetes components, such as API server and others. Yeah. Okay, about security is another key point for Chaos Match in this version. We implement authorization mechanisms based on Kubernetes IBAC. Users can create a specific service account with a limited authorization, and then use the token generated by this service account to log in Chaos dashboard. And here is also an example on Chaos dashboard. When you log in Chaos dashboard, we will find this page, and if you don't know how to use the token, you can click here. The Chaos dashboard will guide you to generate the token and buy this. Okay, and also in Chaos Match also support to enable or disable chaos experiment by the annotation of the namespace. In this way, you can protect some important namespace and limit the scope of the chaos experiments. Okay. Hi, Ian. Is the introduction about the Chaos Match version 2?
Yep, looks very interesting. So I think a lot of great new features that have been implemented in Chaos Mesh. Functionality, you have workflows, you have a kind of improved UI, a new set of experiment, Chaos D. So you will be integrating that as well in the new version. So a new set of experiments look very good. Some are very cloud native, some are generic. So I think pretty interesting going reaching towards your goal to make chaos chaos engineering easy for everyone. So I think that's pretty cool.
Yam, do you have any question, or just I can continue the about the future plan and about the roadmap?
Yeah, I think there is a question like on the comparison of Litmus with Chaos Mesh. I am putting a answer to that. Maybe you can add more to it. I've actually put there. There's a question like, what is the? I mean, you have Litmus and you have other tools. So basically, Chaos Mesh provides native orchestration, meaning that users do not need to rely on external tools for conducting chaos experiments. Plus, Chaos Mesh has Chaos D, a toolkit for injecting into the physical nodes and providing more possibility of chaos tests. So apart from this anything else you would want to add? Please feel free to.
Chaos D, this future is that a single components, and also we will do more things on these components, and will be combine the Chaos D and the Chaos Mesh together in the next version, and you can use this to inject the failures on the on node Kubernetes nodes, and also you can inject failures on Kubernetes node on a unified dashboard. And maybe you can see that in next version, and also multiple Kubernetes clusters that is also will be supported in next version. Okay. Oh, and and the next is about our future plan about the Chaos Mesh. Yam, I will continue introduce about the roadmap of the Chaos Mesh. Okay.
Yep.
Okay. Yeah. And in the future, we will continue to focus on ease of use and observability, such as we plan to measure and schedule chaos on Kubernetes target and non-Kubernetes targets and on a unified dashboard. And also we will support the multiple Kubernetes clustered on a unified dashboard and also. And also we will provide more comprehensive status inspection mechanisms and reports. And we will continue to improve the observability with event logs and metrics. About security, we plan to improve the authorization system and support using GCP or AWS account to log in Chaos dashboard. So if you install Chaos Mesh on GCP or and AWS, we will support this feature, and so you can use this account to log in Chaos dashboard directly. It's very easy to use for users. And then and also we will develop a new components. We develop the future on chaos control, and this component to force recovery chaos experiments and to prevent experiments some chaos for injection out of the control. And also we will plan to provide a plugin for users to explain a complex chaos time. Users can use this plugin to develop their own chaos time, such as RabbitMQ chaos and Redis chaos, or some web chaos and so on. And also we will build a hub for users to share their own chaos workflow and chaos times and also chaos experience. So and the users and the new users can find some workflow and chaos time to use their own environment directly, and this will be reduce the cost of the new users on their first chaos experiments. Okay. Hi. Okay. Next is about demo.
Yep, very excited to see how it works, how it looks like in action.
Okay. Maybe for most users can try CalcMatch easily and quickly. CalcMatch website provide interactive tutorials, and this tutorials is contributed by CalcMatch community's member Jonathan and built on Catcoda. And this time we also use interactive tutorials to show this demo. Because maybe the most people and all people can try these tutorials on CalcMatch website. So we use this to guide the user to how to use these tutorials to try the CalcMatch quickly. Okay, in the beginning, this interactive tutorials will introduce some basic information about CalcMatch, and also also will introduce what you can learn from these tutorials. And here you can start clean here to start scenarios. You can start this demo, and then we can clean here. Yeah. Yeah. First, for these scenarios, CodeCada will be started a free Kubernetes cluster for this demo, and also you can clean this share command to run this share command, and here we run this command to verify the Kubernetes clusters, and here we just clean it. This command will be run. Yeah, you can see then the Kubernetes cluster has been installed successfully, and the version is 1.21 version, and this cluster has 2 nodes, and one is master node, and another is a non-master node. And then we need to make sure the Helm has been installed on our Kubernetes clusters, because and here you can use the Helm version to verify the to make sure the Helm is installed in CalcMatch in Kubernetes clusters, because in the next step I will use the Helm to install CalcMatch, and here is a screen. This screen will be use a default service account to generate a token, and you need to use a token to access our Calc dashboard. And where we can run this, we will generate a token. You need to remember the token and use it to log in on Calc dashboard. And here we can copy it. And here this command is just to make sure the Kubernetes dashboard is ready. Okay, next. Next is about install CalcMatch. First, we need to create a namespace for CalcMatch, and here we use the CalcMatch this namespace, and also you can use other namespace such as Calc testing or others other namespace you like. We just clean it, and here then CalcMatch namespace has been created. You also can input some command to check it. We can see that CalcMatch namespace has been corrected. And here next we need to add the chart repos to the Helm chart. And here we just clean here. We just will add the CalcMatch chart into the Helm repo. And here we also can check it. Helm list. Helm repo list. Oh, we can see then the CalcMatch. This chart has been added the Helm chart Helm repo. And this command is install command. You can just click here. Yeah, Helm install CalcMatch, and we need to specify the Helm chart version, and specify the namespace chaos match, and here we create it, and here. And when finish this command, we need to make sure all chaos match pod is ready, and we can run this command. And also we just can clean here to check the all chaos match pod is running. Are running. And here you can see then I has introduced and the previous slides chaos match include 3 components: chaos controller manager, chaos daemon, and chaos dashboard. Yeah, we can we need to make sure the all components are running. And here. Yeah. And here we can see then the 3 pods are running and it's ready. And then. And here this command, next step, we just to patch the service, chaos dashboard service, we to set the node pod to a specific pod for all users can access the chaos dashboard. And we clean here, and here is you can open the chaos dashboard to clean these URLs, or just to clean here. Yeah, you can see then we need to input the token, and here we remember and before, and also we need to input a name for this token. We can free to input. We just input admin because this token is a classroom, so we name this admin. Yeah, we can see then we have login chaos dashboard, and you can see then this overview page, and we will show some overview information about the chaos match, and here how much experiments and the schedule and the workflow is running, and you can see then the timeline and the recent events, and also status, and also you can create workflow, and here schedules, and here and the experiment. A single experiments, and here, and also and other steps. Okay, let's continue. Oh, this continue shows some chaos times, so you can create, you can use the in chaos match. And next, for this demo, we need to install an example application as a target for this experiment. And here we will install a WebShow application. This application is decided by the chaos match project as a Hello World example for your first chaos experiments. Yeah, you need to install this application. You need to create a config map for it and set a target IP for this application. And here we need to run this, and we'll create a config map for this application. Yeah, and the config map is corrected, and then we will create the WebShow application, and this application will be run as a deployment. Yeah, and then we will create a service for this application for users can access the WebShow application. Yeah, before access the WebShow application, we need to make sure the WebShow application is running. We can clean this command. Yeah, we can see that. Oh, maybe we need to some more time to create this application. Yeah, maybe we need some more time. Wait a moment. Wait a moment. Oh. We need to make sure this application is running. Yeah, here the application is running. Yeah, And here you can clean this URL or just open this to access a web show application. Wait a moment. Yeah, you can see then it is a web show application. They just record the latency between the web show pod to the Kubernetes system pod, and we will show the latency on this chart. And this we can see then the latency is below 1 millisecond. Yeah. And let's return our tutorials. Next, we need to define a chaos experiment. For this demo, we just use the YAML files. And here you can get CRD. This CRD define different chaos times, such as AWS chaos, IO chaos, network chaos, and so on. And here, first demo, we just inject a network delay on web show application, and we can see then, yeah. And this is this example about the network chaos is latency is 10 milliseconds, and user selector namespace is default, label selector is a web show, and the action is a network delay. And when we use a kube apply command to create these chaos experiments. And also, before we create this experiment, we also can use this label to make sure we can select the target application, target pod. Yeah, you can see that we will see the web show application. And then we just kube apply, run this command. Yeah, and then you can see then. You can see then this network chaos has been created, and because it's just a single chaos experiment, when we create this CRD object, the chaos will be the full injection will be work. Oh, okay. You can see then the network and the latency has turned to 10 milliseconds. Yeah, the chaos is working. If you want to store this, and also you also can observe the chaos on our chaos dashboard, and here you can find it. You can clean it. Here is the events from events of the chaos experiment. You can find some detailed information about this chaos. You can see then, wait a moment, yeah, you can see then apply chaos for this pod. And here is definition. If you want storage, you just clean here. If you want to delete it, you also can clean here. And here we, for this demo, we just delete it. Yeah, we can see. Oh, yeah, you can see that the network latency has returned to normal. And the next is about the security schedule. Is a schedule object. If we want to create a chaos with cron rulers, you can use this, and we can see then. It's kind is a schedule, and define a schedule ruler is every 6 seconds, and this chaos injection lasts 30 seconds. And here we can just apply it. Yeah. Wait a moment, maybe we also can see then. Yeah, you can find then this schedule object has been created. Wait a moment. Because we schedule ruler is every 30 seconds, so the chaos action will be work on the next term. Maybe we need to wait for 30 seconds. Wait a moment. Oh, wait a moment. Okay. Wait a moment. Yeah, you can see then. The chaos and the for injection has work, and the network latency turn to 10 milliseconds, and also can see then the events. You can see then the schedule object will be create a single network chaos, and the chaos will last 30 seconds, and then will delete this network chaos, and with the next turn we will recreate the network chaos. Yeah, and here for this you can see then the latency has returned to normal. For this we just delete. Yeah, just delete. Yeah, and chaos dashboard also will record record all the all network chaos, all chaos and schedule and workflow you created before. If you want to recreate it, you can just use the load from. You can see then. If you will want to create a new experiment, you can look from. You can see then we will this chaos is created before. You can use this to again and to recreate this chaos. And also you can use the workflow to define a single task or series or parallels custom task. And here, yeah. Okay, and this demo is about the pod chaos. In this experiment will be simulate some pod is queued, and some pod is recreated by this demo for the okay. Oh, let's finish this demo. Any users if you are interested about the chaos experiments or chaos match, you can click here to try chaos match quickly. Yeah. Okay. Okay. My demo is in. Oh, next. Yeah.
Yeah, that was an amazing demo, and I have a great response from the community as well. So I shared this interactive tutorial link in the session comments, and there are a lot of people who just want to try it out. So definitely you'll be seeing some of the folks giving it a try. So it actually looks very, very cool, because you can try it very easily using Katacoda. And all the guided tutorial makes it very simple. All the steps make it very simple, as we have shown. So pretty neat demo, and yeah, great for folks to try out Chaos Mesh. So yeah, let's cover the how we can get involved, how the users who are watching can get involved in the community. I think that also is very important aspect, because community is what is driving the open source initiatives, the cool projects out there. So how the community can join Chaos Mesh, contribute to Chaos Mesh, anything on that?
Oh, okay. I think it's turn to Kevin. I will still share my screen.
Sure. Let me share my desktop. Okay. Sorry. Yeah. Thanks, Chenwen, for the wonderful sharing about Chaos Mesh architecture and the 2.0 features and the great demo. Yeah, just like Saim, just as Saim just mentioned, it's all these wonderful things happens because of the community. So here are some ways to join us in this Chaos Mesh community. But before that, I would like to share some great news in the community. Firstly, as I mentioned in the beginning, Chaos Mesh has been in the CNCF for 1 year. And it's really wonderful to see the great growth within CNCF. So we're actually actively preparing and for the incubating stage of Chaos Mesh. That's one, and the other is we just hit the 100 contributor milestone in the repo. Yeah, which is really great. Yeah, here is the full list of Chaos Mesh contributors, and hopefully after today's session, we will see more and more contributors from the community. Yeah, to join us, firstly, of course, you need to try it out. Like you can start very easily from the Interact tutorials, which Chenwen just demoed, and you can install and deploy Chaos Mesh yourself, which is really easy, just using this one line of command, which that will set you up very quickly. And for other ways to join us, after you try it out for some time, you can reach out to us for bugs, for proposing new features. You can also add a new Chaos type and write documentation for us, etc. Also, if you are familiar, you've been playing around for a while, you're getting more and more familiar. You have something to share, you can write about us. You can read blogs. We have seen so many great blogs, articles from multiple channels, from multiple communities. And you can ask or answer questions that posted in the community. Or you can, speak about us in the conferences. In return, we will ship you like very cool swags designed by our community for free. Here are some guide for you to refer to when you contribute to Chaos Mesh. If you have some questions, you can join our Slack channel, Project Chaos Mesh, in the CNCF Slack. Okay. As I mentioned earlier, in CNCF, Chaos Mesh is not the only chaos engineering project. We also have Chaos Blade and Litmus Chaos. We also have many tags, CNCF tags that's related to chaos engineering, like tag application or tag security. And the chaos engineering, of course, it's a very big scope, and to establish the standards for cloud-native chaos engineering, it's a very big goal. We cannot achieve it without collaborating with other projects. So actually, we are just forming this new working group in CNCF, which is initiated by Tech Application, Tech Network, and other chaos engineering projects, including us. So our goal is to help establish chaos engineering as widely adopted practice for cloud-native application development. So if you want to know more about chaos engineering, if you want to really adopt chaos engineering in your system, this is a very good place to go. If you have something to share, or you want to provide your feedback here, you're welcome to take the Cloud Native Chaos Engineering survey.
Yep. So
yeah.
Go ahead.
Oh yeah, just one more thing. Another important way to participate in the community is the LF mentorship program. It's just open for project application for the 2021 circle. Yeah, you can click on this website, this URL for more information. Chaos Mesh has been very active in the mentoring program. We have been in the program for 4 times, and three mentees have actually successfully graduated from the program, and then becoming a long-term Chaos Mesh contributors. And we will provide very great mentorship for this program, and we'll take you through this program step by step. Yeah. Okay. Yeah. These are just other regular channels you can find us. Yeah. Join us.
Yeah, thank you, Kelvin, for all this information. Very important. I have shared all the links that Kelvin just mentioned while he was speaking. So I was just finding all those links and putting them in the chat so that you can join the amazing community. You can join CNCF Slack and join the Project Chaos Mesh channel. You can also find them on Twitter, and also posted the GitHub links for that. The LFX mentorship, and also the contributing guide that was just shown. And I am also actively involved in the working group, which was just mentioned. So we have like bi-weekly meetings. I am representing kind of end user experience over there, putting a strong point for the end users. So that is pretty interesting group that we are going. Our end goal is kind of a white paper that we all agree to, different chaos groups agree to. So I think that would that would be for the betterment of end users, and everybody, kind of all the projects aligned towards the benefit of the end user. So in the end, basically the end user is the one who will be getting benefit of from all the chaos tools out there. And definitely Chaos Mesh, Litmus, they both have a very strong representation in the working group, as Kelvin mentioned, because they are also driving towards the betterment of the community, and for you to use the tools. And obviously when you contribute, you get swags. So I mean, swags come automatically with your contribution, so make sure you do that. So yeah, very interesting session, and people have loved this. So you can see actually all the comments. So thank you all for tuning in. Yes, I have been seeing all the tweets, and I have the winners with me as well. So we have 3 winners. So drum rolls, please, for the winners. So the first one is Yash Vasalwar. And congratulations and thank you for the awesome tweets. So I would request Kelvin and Chengweng to just go on Twitter and see the Twitter threads that people have been creating. So very good. Second is Andrila Das. So again, congratulations. And third one is Pragya Bansal. So again, congratulations. So congratulations to all 3 winners. My Twitter DMs are open. Please send me your email IDs, and I will forward it to Chaos Mesh team, and then they will coordinate you with your shipping address and all those information. But please give me your email ID so that I can forward it to the Chaos Mesh team. So congratulations to Yash, Andrila, and Pragya. And so glad that you have stayed till the end. And obviously there are a lot of people who stayed till the end, but congratulations, and keep learning. These sessions keep on going on. Swags will come along the way, and awesome projects like Chaos Mesh will be discussed on a lot of sessions coming up in August. So make sure you subscribe to the channel, share it with your friends, because that motivates me a lot to put my extra effort and extra time for doing these sessions. I personally obviously learn a lot and make a lot of friends like Kelvin and Chengweng. I have already interacted more than a couple of times with them, but yeah, these things keep continuing. So Yep, that's pretty much it. Anything else you would like to add, Kelvin and Chengwing, to for the community? Any message that you want to put out?
Nope, I just yeah, that's really a great session, and we really enjoyed it a lot. And thank you guys, and thank you everyone who stay online with us. Yeah, I hope we can continue this communication. Not, I mean, we are not stopping here. We can continue our discussions and communications on Slack, on GitHub, anyways in our community. Yes.
Absolutely. So make sure you join all these channels. Try it out and also be like one of the contributors.
Yeah.
Okay, everyone.
Okay.
So thank you all, and thank you so much, Kelvin and Chengwing, for your time. So I know it's kind of late, but really thank you that you stayed up late till the night and for this particular session. So really appreciate that. And thank you all for tuning in from different parts of the world and sharing your learnings in Twitter threads. So with that, see you in the next session. Bye.
Bye.